global problem. Let's talk about two types of pollution. So the first problem is CO2. So people release about 37.1 billion tons of CO2 every year. And the second is trash. So people throw away about 2.1 billion tons of trash every year, and that's really bad for the ocean because about 7 million tons of that goes into the ocean, which affects a lot of plant life. And if you look at the top picture, there are 4 main trash islands in the ocean today, and one of them is even surrounding the US and Africa. And so these main trash islands are located all around the world. So if you look at the map on the bottom, you'll see that the biggest sources of plastic, marine debris, which is basically just plastic that's in the ocean, and the biggest contributors are India, the US, and China. So then onto chemistry. So algae is eating the food and CO2. I'm going to start explaining my contraption here. So basically, this is a food separator, so it'll separate the plastic from the food waste. The food waste goes into the tank, which has algae in it, and the algae will eat the food. When all the paper and the plastic and all the debris that are not edible by the algae go into the incinerator and get burned, which creates CO2. The CO2 goes into the CO2 goes into the rises into the goes into the algae, which is then consumed by the algae, which causes the algae to grow. And since the algae is growing, it can eat more CO2 and more food debris. Obviously, I can't burn stuff because this is school. I wish. Okay, so now going on to math. So, how do you go back?
Escape?
Escape.
Well,
Oh.
okay, maybe not.
Okay.
You needed to use the back button.
Use like the arrow key.
Exactly. That's what I mean.
Oh, you said back button.
Where-
That's the same thing, right?
No.
Yeah.
Go to the
Oh,
right.
the arrow
Yeah.
keys mean
okay,
different.
there you go.
No, your face.
Okay, cool. So, oh wait. Yeah. Okay, wait, no. There we go. Okay. Yes. Okay, so for the first half of the slide, for chemistry, it shows the equation for photosynthesis, which is what the algae is doing to get bigger, and that way they can consume more food and more CO2. And then the bottom is how the algae breaks down the food. So it's showing table sugar being broken down into glucose and fructose, which help the algae grow. So let's do the math. So we need to scrub 37 billion tons of CO2 in order to counteract the amount of CO2 that there is in the world today. And so the way we can do that is, so the algae would take up approximately 4,670 Olympic-sized swimming pools, but this actually isn't that unrealistic to do in real life. In order to present this information, I had to write a slideshow in English and also a research paper using the English language. So then I have lots and lots of sources.
Wow.
And any questions?
Okay, well,
Where would the algae and water be contained? Like would this be multiple facilities or just one huge facility?
So it could be either. It could be stored in one facility with all the water and all the algae, or it can be stored in multiple across the planet. Any other questions?
so you said that you want to remove all the CO2 from the earth with
No.
this?
So what I meant by that
We
was
need
like,
some?
yeah, so what I meant was we need to, since there's a lot of CO2 on the planet being caused, like every minute there's more CO2 being released into the air, we need to try and counteract that. That way we can help the planet. I'm not saying get rid of all the CO2, I'm just saying get rid of a lot of it. Because right now, as I said, yeah, so there's 37.1 billion tons of CO2, so in the air just being released by trash, and so the way we can counteract that is with the algae scrubbing only like 12 billion tons of CO2. That way we still have excess CO2, but we are getting rid of some of it.
what is the potential effect of too much CO2?
The temperature will rise, causing people to migrate, and obviously the trash will get hurt the sea life, and it will also cause people to migrate.
Jaden had a question.
Do you know how fast the algae will actually break down the material? Because think about it, like if the algae breaks it down too slow, then that means the amount of trash that goes into daily life of normal U.S. citizens, it might not be fast enough to actually keep up with how much it's being produced.
Yeah, so so it shows that a 2-liter algae will scrub 24 pounds of CO2 every year, and so that's why we would need about 3 billion liters of algae to clean it yearly. And so if we have that much, then it'll only take about a year if we have 3 billion liters of algae to clean all that. And so I mean, it just depends on how much space you have to do it. So I mean, the more space you have, the more algae you have to clean the CO2 from there.
Thank you.